So first off, you've been asked to take d squared y dx squared, and this is just the second derivative. They just want y double prime. So that means we're taking the derivative of this, where u equals 3y minus 2x, and v equals 8y minus 3x. So we need to use the quotient rule. That means u prime will be 3 times dy dx minus 2. And that means v prime will be equal to 8 dy dx minus 3. And so y double prime will be u prime v plus minus v prime u all over v squared. And instead of plugging everything in and making this ginormous garbled equation, I'm going to go back and make everything into numbers to clean this up. So the first thing I'm going to do is recognize that dy dx equals 3 times what y is. And remember, from part B, we had 3 for x and 2 for y. So that means we've got 3 times 3 minus 2 times 2 all over 8 times, oops, I think I've switched these. Let's see. This is 2. 3 times y is going to be 2 minus 2 times 3. Here minus 3 times an x coordinate of 3. Well, it turns out that 3 times 2 minus 2 times 3 is just going to be 0. So everywhere I see a dy dx, I can use 0. Similarly, I'm going to plug numbers in here. So we said that was 0. So that means u prime equals negative 2 and v prime equals negative 3. And also plugging in for u will equal 0 and v will equal 8 times 2 minus 3 times 3, or 16 minus 9 equals 7. So now I'll go through and plug everything in where it goes. U prime we said was negative 2. V was 7. So now I've got everything I need. U is 0, V is 7, V prime is negative 3, U prime is negative 2, and any time we need a dy dx, that's equal to 0. Plugging everything in, U prime is negative 2 times V is 7 minus v prime is negative 3, u is negative 2, v is 7 squared. So we have negative 14 minus 6 so I've uncovered a small error here. U is equal to 0. You may have already seen this. So this is correct, but this negative 2 should be 0, meaning that we have negative 14 minus 0, or negative 7 times 2 over 7 squared. A 7 will cancel with one of these, and my answer will be negative 2 over 7. So that is the second derivative at point P. That means that I'm concave down, because whenever y double prime, or the second derivative, is less than 0, we have a concave down behavior. So they've asked, does the curve have a local maximum or a local minimum, or neither, at point P? Well, point P, we said, was the x-coordinate of 3, the y-coordinate of 2. In the part B, we showed that the slope, m, was equal to 0, or dy dx was equal to 0, because they told us that we had a horizontal tangent. And now we have the second derivative, d squared y dx squared, equal to negative 2/7. So that means we have a concave down function with a 0 slope right here at the coordinate 3, 2. So that means we have a max. And we've proved that with this information. Slope is 0, and the second derivative is negative, or concave down.